When we are dealing with trig functions, cosine, sine, tangent, cosecant, and so forth, we always have to be a bit careful. So I want to show some of the first limits we can calculate using trig functions separately in this video. Something that's not hard to see, even though not formally mathematically, we have to prove it with more care, and we'll do that in a separate video, but the direct substitution property, so this idea that if you want to calculate a limit when x approaches a for cosine is just the cosine of a. This is easy to see from the graph of cosine. Cosine is this green as this red one. And if a, let's say a equals 0, then you can easily see that we're approaching the right place of the graph. The graph is solid, unbroken. A word for this is continuous. This is a definition that we're going to define on a separate video, but the graph is well behaved, well defined, unbroken. There's no holes, there are no jumps. So this direct substitution property holds. As an example, and I'll use my blue ink now, the limit as x approaches 0 of cosine of x is just the cosine of 0, which is, if you remember from trigonometry, is just 1. And then the limit as cosine of x is, sorry, I want to do sine now. So the limit of sine of x as x approaches 0 equals just to the sine of 0, which is just 0. So you can do that with pi over 2, whatever angles you want, but it's just good form. We always do those in radians. Remember that. We're never doing those in degrees unless I tell you otherwise. Always doing those in radians. So x is always an angle that's measured in radians. So just as a secondary example, the limit as x approaches pi over, let's say pi over 6 of sine x is just sine of pi over 6, so just plug it in. So that's just 1/2, okay? So another example that would help you remember that radians are the units of measurement that we are using. However, there are some difficulties. There are always some difficulties, and we're going to start dealing with them in a couple of examples. Here's the first one. The limit as x approaches 0 of sine squared over 1 minus cosine squared. We're going to use some trig identities first. Trig identities. And then factor and cancel. Most of the time, these two together are going to be enough to solve the entire thing. So if you recall that sine squared x plus cosine squared x equals to 1, you're going to be able to replace that sine squared on the top of this fraction by 1 minus cosine squared x. 1 minus cosine x. And now you're going to use the difference of squares to factor out the top, a plus b times a minus b, right? A squared minus b squared. Your a being 1, your b being cosine x. So 1 minus cosine x, 1 plus cosine x. It's 1 minus cosine x. And now that these two can be canceled out, the answer will be just the limit when x approaches 0 of 1 plus cosine x. And there's no issue with this. When x approaches 0, the cosine of 0, I can just plug things in. That's 1 plus the cosine of 0 radians, which is 1 plus 1, which equals 2. Remember, if I wanted to, if I could have done that, I would have just plugged this in originally at the very beginning, but that would give me a 1 minus cosine of 0, which is 1 minus 1, which is 0 on the denominator of this fraction. And I don't want that to happen. I want to avoid that, which is why that forces me to factor and to cancel. Use trig identities to then factor and to cancel. This happens to b as well. So on b, the limit as x approaches 0. First thing that I will use is I will use the double angle identity, so the cosine of 2x, that's 1 minus cosine squared x minus sine squared x. So that will be divided by sine x. Distribute this minus sign first of all, right? I'm replacing first of all this with this. Then now I'm allowed to distribute this minus sign, so this is 1 minus cosine squared x plus sine squared x. Sine x. Again, if I wanted to plug in 0, I wanted to, not if I wanted to, I did want to, but the sine of 0 equals 0 at the bottom there. I can't do that. So I'm going this route because I can't just plug in right now. I have to factor and cancel to then plug things in. But another use of this trig identity, 1 minus cosine squared x, this is going to be sine x by this Pythagorean identity there. So this will be sine squared x plus sine squared x over sine x. And I'm meaning to say that this equals this. So that makes it so that the limit when x goes to 0 of choose sine squared x over sine x. Now I'm allowed to cross these two out. That's just the limit when x goes to 0 of choose sine x. Now there's no issue with divisions by 0, so that's just a 2 times the sine of 0. The sine of 0 is 0, so that's 2 times 0, which is 0. So I hope that was helpful. I hope you were able to recall some of the properties. So here I used this Pythagorean identity. Here I used a formula for the cosine of the double angle. This is a pre-calculus skill. I hope this was helpful.